what we're going to be talking about today is we're going to be doing monomials. So go ahead, copy this down on your notes. And a monomial is a number variable or a product of number and variables. So product means multiplying. And I gave you some examples: -7, 3x, 1/4 xy, x to the 7th. And when you're looking at the 1/4 xy, it's really 1/4 times x times y. And you got x to the 7th, negative y to the 5th. And then you also have -5/2 times x times y to the 4th. And then negative times the 6/11ths. So monomials with the same variables and same exponents are like terms. So to add or subtract monomials, you combine like terms. That's very important. You do not change the variables and the exponents. You just combine like terms and leave the variables and exponents as is. So let's go ahead and let's get started. All right. So first what we're going to do is we're going to look at number 1, and we've got, let me zoom in here, got 4x and 5x. So notice they both have x's, so all you have to do is combine the coefficient. The coefficients are out front, so +4 and +5 give you +9, and you leave the variable as x. That's it. So coefficients are the numbers multiplied by the variable. So now let's look. The variables must be the same and have the same degree or exponents to be like terms. So let's look at number 3 as we zoom in here. I've got 7m squared minus 9m squared. So we've got, they have m's, so that's good, and they both have 2 as an exponent. So that means they're like terms. So all we have to do is look at the coefficients. We have 7 as a coefficient and -9 as a coefficient. So yes, that's a subtraction sign, but subtraction and negatives are the same. So you're going to combine them, and you'll get -2m squared. So leave the m squared as is because it's they're like terms. You don't change those. All right, now let's look at number 5. I've got -3r squared s plus 11r squared s. So they both have r squares, they both have s's, and remember you're technically multiplying r squared times s for both of them. So therefore, those are both like terms. So now all we gotta do is combine your coefficients of -3 and +11. And you're going to get 8. And then leave the r squared s as is because you're combining like terms. All right, let's go down to number 7. We've got one thing we need to do first, but it's 15ab cubed minus a -15ab cubed. So I'm going to rewrite this because remember the two negatives right next to each other make a positive. And then now let's look at your variables. They both have to be the same as a b cubed, and then this is a b cubed. So since they're both the same variables powers, all you gotta do is add the coefficients. So 15 plus 15 is 30, and you leave the variables as a times b cubed. All right, down here now we've got a couple different variables that are separated by your addition or subtraction signs. So we're just going to combine the m's right now. So you've got a -3m and a -5m. And combine those together, you're going to get -8m. Now let's look at our n's. Got an n there, got an n there. We've got a -2n. And then the coefficient for the n is 1. I like to write the 1 in there so we don't forget, but it's technically 1 times n. So you're going to go -2 plus 1. And you're going to get -1n. And usually we don't write it like that. Usually you'll see it as just n. But bring the rest down, 8m minus n. And then also we typically go in alphabetical order when we're writing this down. So m would come before n, and this would be the standard answer. Now you may see as -n minus 8m, and those are the same thing, because as long as the sign's attached to the correct variable, you can move them around. But however, the negative 8m minus n is more correct as far as standard form. But they're both equivalent amounts. All right, let's move down to number 11. Now here we all have k's, but now we need to look at the exponents. So here, the first one, we have k squared, and we have a k squared. So remember, it has to have the same variable and exponent in order to be like terms. So we're going to combine the 7k squared and the positive 12k squared, and you're going to get 19k squared. And remember, k squared is the same as k times k. It is not the same as k. That's why we can't combine them. So that's why k squared and k are not like terms. All right, so now let's combine your k's. So I've got negative k and a positive 4k. And remember, the coefficient of k is technically a negative 1. So now we're going to combine negative 1 and positive 4, and we're going to get positive 3k. So combine it together, 19k squared plus 3k. And in this case, since they're both k's, you put the power, the bigger exponent first. So this would be more correct. You could also write it 3k plus 19k squared. That's equivalent. However, that is the more correct form as far as it's in standard form. I'd mark you correct on both versions. It's the same thing. But if you had to enter it on Canvas, you would want to put the 19k squared first. All right, let's come in and let's go to 13. There we go. All right, so we have 8c squared minus 4cd plus 3d squared minus cd. So remember, it has to be exactly the same in order for them to be like terms. So I've got a c squared, but I don't have any other c squared. So that's it. That's as far as I can simplify that section. So now I need to go through and look for the next one. And it is important to note that cd is not the same as c, because cd is technically c times d. And so you can't combine those at all, even though they both have c's in them, because they're different operations. So now let's look for the cd. So I've got negative 4cd and I've got a negative 1cd. And you're going to combine those together, and you're going to get negative 5cd. And then now let's look at the last term, which is d squared. And there's nothing else to combine with that, so you just bring that down. Oops. And then that's as simplified as you can get, because you can't combine any of the other ones. All right, so let's go ahead and let's look at this next one. Find the sum of 8m to the third n squared. And remember, sum means that you are adding. And you're going to add a negative 3m cubed n squared. And you can put in the parentheses first, but just know that when you simplify them, you're really doing 8m to the third n squared minus 3m to the third n squared. So they are like terms because they both have an m to the third times n to the second. So both like terms. So since they are both like terms, all you gotta do is combine your coefficients. And you will get 5m to the third power n to the second power. All right, so what you're gonna do is you're gonna go back and you're going to complete the highlighted ones. And for 16, it's subtract negative 4xy from 2y. So it's actually going to be 2xy minus a negative 4xy. All right, now let's go ahead. Let's look at this one with exponents. Turn your paper over. And it says, in the case of repeated multiplication with the same number, we can rewrite the expression using exponents. So for example, we've got 4 times 4 times 4. That's 4. And we have as the base, and 3, there's 3 4s. So that's 4 to the third power. So the base is the number, like 4 would be your base in the example above, and then n would be your exponent, which matches the 3. And you read it as x to the nth power. All right, so now let's go ahead, let's do expanded notation. Expanded notation is similar to factoring out. So we're just going to take your base and count how many times you have your base. So we have 11 times 11, so 11 is your base, and we have it twice, so that means your exponent is 2. And then value is just where you multiply it all out, and so that's basically 11 times 11, which is 121. All right, you're going to do this next one with the 2's. And you just count how many 2's is your base. Now let's come here, we got -5. Now notice that -5 is in parentheses. So remember, if it's in the parentheses, or the negative stuck to the number. So your base is -5, and you have 4 groups of -5. So that's -5 to the 4th power. And if you're to multiply all this out, it's like going -5 times -5 times -5 times -5. I'm not going to write all that, just it's already there. But if you go ahead, and I'm fine if you use a calculator now, but that would be a positive 625. All right, now let's look at this one. You've got 1/4 as your base because it's in the parentheses, and we've got 3 1/4. Now, you can write it as 1/4 to the 3rd, but you just need to make sure that the 3 doesn't look like a 13. That's why I like to write it in parentheses. So that's why I just rather you keep it that way. But really, you're going to multiply 1/4 times 1/4 times 1/4. And so therefore, 1 times 1 times 1 is 1, and 4 times 4 times 4 is 64. And that's the value of it. All right? You're going to go ahead and you're going to try the next one. I'm going to come down here where I've got a couple different ones on here so I can show you guys what to do. So let's go ahead, let's do the 8s. I've got 8 is the base, and there's 4 8s, so it's 8 to the 4th power. And then now let's look at your -2's. Again, remember the negative's attached because it's in parentheses. So -2 is the base, and we have 3 -2's. So then you're going to multiply all that out. Again, you may use a calculator. I'll show you how to do exponents on your calculator if you don't know how. But you're going to get a big number. And it's going to be -32,768 is the value if you were to multiply all of that together. All right, so make sure you finish those other ones. And then we're going to come down here and we're going to do some of the ones with the variables. All right, so let's count. A is the base, so let's count the number of A's that we're multiplying together. And we've got 9 of them, so it's A to the 9th power. Now here we can't find the value because there's no number, so you can just cross that box out. Same thing with these other few because there's no numbers to multiply, so there's no value for that, so you can cross that out. All right, let's come down and let's do this next one. And we have a mix of K's, so number 11. So we're going to count our K's. K is the base, and we've got 6 of them. And now let's count our 9's. So 9 is the base, and you've got 3 of them. And you're technically multiplying this together. Now, usually when we write this, we usually put the number first and then the variable. Again, that's part of that standard form on there. But then since we do have numbers to multiply out, now we're actually going to find the value of that part. 9 to the 3rd power, and you go 9 times 9 times 9, which is 729, and then we keep K to the 6th power because we can't find the value of that because it's a variable. All right, so you're going to try the next one, and then I'm going to do this one down here for you because you have an expression in parentheses. So it's P minus 2 is the base, and you have 3 groups of P minus 2. Now again, that we can't really find the value of, so we're just going to cross that one out. But for 14, you can multiply the 6's together, but look at your base. Your base is A plus B. All right, so just make sure you multiply those 6's together, and that's going to go in front of your A plus B in parentheses squared. All right, so make sure you're paying attention to your base, to your exponents, and you're going to complete all the highlighted ones. And then remember, if you have any questions, make sure you're checking your answers and you're asking for help if you get stuck. Get as far as you can. And then that's your exponents, and then that's your monomials.